Hello, Mr. Aaron, Mr. Ryan. How are you today?
Good.
Okay, so today we talk about interesting topic, a rocket. That's Mars, yeah, Mars. And we are coming from the Earth. And then we have a rocket,
I
yeah?
need to begin with a capital letter.
Okay,
Because
okay. It's what?
it's a name.
Special noun, yeah? What do you call that?
A proper noun.
A proper noun, yeah.
Proper
the Earth.
noun.
The Earth. And we need a few spaceships.
You don't
yeah?
need to call them.
Okay, we have a few spaceship rocket, yeah, and we have a list of people like the weight. Let's say 100, 200.
That's gonna be
200.
a very heavy people.
Yeah, 400. You know, all the.
Are you kidding me?
Yeah. Okay, and let's say each spaceship, each rocket can carry the limit 400. Yeah, limit is 400, and each spaceship can only carry at most 2 people, right? 2 people. So how many spaceships, the minimum number of spaceships do we need to carry all those people? If the maximum weight of each people is less than the limit, right?
3.
Right? If there's 500, we can't do this, right? Because 500 can't put into the spaceship, right? Yeah? So let's say if we know all the people, the maximum weight of the people is less or equal than the limit. Okay, so how many do we need? How many here?
3.
Can you tell me what are 3?
You can do 100, 200, 200, and 400.
100, 200, what? And then 200, yeah? Another one. And 4. Sorry?
Wait, so,
Yeah? Come on.
yeah, and 200 and 400.
Yeah, that's 3. What's the strategy of doing that? I mean, how can you? All we can do is 200, 200, and 100 and 400, right? It's the same, yeah. Okay, so let's say if I have another 200 here.
What?
No. If we have another 300 here, so what? How do you do this?
Then you say a 300 because there isn't any 300 people.
Sorry, what do you mean?
You then say another 300 because there.
Okay, 300. Okay, so there's a 300. So how should we organize this?
100, 300, 200, 200, 400.
Yes.
So this.
Okay, so what's the strategy?
Oh!
Wow.
Okay, so you're trying to find combinations to the target. So it's no limit, which is that.
But if there's no, right? If this is 250. Okay, so what? If this is 180. Okay, so what
So this.
Okay, so what's the strategy in this case?
Okay, so well.
So what are you trying to do here? Obviously, these are just side numbers, yes, but it's easy to see.
So we only can have 2.
Yeah, because we
maximum.
Yeah, because only one spaceship can only carry 2. So what?
They must be very small.
Very small. Sorry. So what happens if I pick the most heaviest? Okay, so for example, this is 400, yeah, the spaceship. If the current maximum is 400, yeah. Or maybe let's say if just that 300, yeah. If the current maximum is 300, this is the most heaviest here. Right? I pick the most heaviest one. So because I only can pick one here, so do I pick the second heaviest or the most lightest?
Lightest.
Why is that?
Because heaviest is not. Okay, so heaviest and lightest has most chance of getting less than the target.
Well done. That's a good one. Okay, so look, Eric. If this lightest one can go in the spaceship, right? Yeah. So it can only.
It's a rocket.
Oh, rocket. It also. What does it mean? It means that the lightest one can also go with any other, right?
Yeah.
Why does that?
Oh!
Yeah?
Because
This is the most heaviest.
Yeah, the most heaviest. So lightest, it must be smaller, smaller than 300, and because it can go with any.
Yeah.
Because this is because we got 100.
Yeah.
And 300. That makes 400, and then that's the biggest.
Yeah.
Greatest, and when you get smaller, it's definitely smaller than the target.
Okay, so I kind of understand what you mean. Look, listen up, listen up. The lightest, look, listen up. This most heaviest. If the lightest can go with the most heaviest, this lightest can go with any other ship, any other weight, right?
Yeah.
Right? Because any other weight is smaller than the most heaviest, am I right?
Okay, that's what I said.
Okay, if the lightest cannot go with the most heaviest, what does it mean?
It means we need to go with the lightest with the second biggest.
No. If this most heavy cannot go with the lightest, then what does it mean? It tells us that the most heaviest cannot go with any other weight, right? Because even the lightest cannot go, then all other weights are bigger than the lightest, right?
Oh yeah.
Yeah? Yeah? Does it make sense? So let's just make it go, right?
Yeah.
Yeah? Okay, so what's the strategy here? What's the strategy here?
Well.
If we saw these numbers, that would be 100, 180, 200, 250, 300. Okay. If we saw this number, does it remember what did we learn yesterday? Remember yesterday what did we learn?
Oh, 2 pointers!
Can we apply that?
Oh yeah.
Yeah, it's the same thing. We saw this. Every time we check the most heaviest, right? And we have the lightest, right?
Yeah.
We check if these two can fit into 400, the limit. Then we go, we move it here. If it's bigger than the most light, that one, then we just let it go, right? Got it?
So it's like that, so it's gone, and then this is 430.
It's bigger, then let it go,
Yeah.
and then move here.
Yeah.
Yeah, together. Okay?
Yeah.
Yeah. Because that's greedy. That greedy strategy. Why is that? I just told you. Because the only one rocket can only have 2 people, right? Yeah. Remember, if the most heaviest can go with the most lightest, it can go with any other, right? No. If the most heaviest can go with the lightest, yeah, this lightest can go with any other, right? If the most heaviest cannot go with the lightest, what does it mean? It can only go by itself, right? Because it's only even the most lightest cannot go with the most heaviest. Then the most heaviest will just go by itself. Am I right?
Yeah.
Okay, that's very interesting, yeah? Ryan, does it make sense, Ryan?
Yeah.
Are you sure you're listening? You sure?
We'll
Okay.
use it more rubber.
No, Mommy said this is cleaner. Okay, define rocket. Rocket. And then we have this weight. And then we have this limit.
Column.
Okay. Look, let's say count. Count is equal to 0 at the beginning. Yeah? And first of all, we need to do what? One thing. What will we do?
Oh, non-stop sort.
Wait.
Wait, dot sort, wherever it is.
Okay, where's the sort? What's the time complexity?
Owen login.
Owen login for this one.
Hashtag Owen login. Booyah booyah.
Okay, enough. So now we have this left equals what?
Oh, 0.
Right.
And minus 1. No.
Length, weight minus 1, yeah?
Yeah.
Okay, so what's next? What's next?
While.
Left?
Left and right.
What? Left what?
Left,
What? Left smaller,
then right.
equal, right, because it can be equal, right? Okay, now.
What, possibly, then all of them must be the same.
What? What do you mean?
If L and R is the same,
It means there's only one. Yeah, it's possible. Yeah, there's only one, right?
it means that all of them must be the same.
No. Left here a few weights, and left here, right here, right? Left and right can point to the same one. It means only one, right? Yeah.
Oh yeah.
Okay. Look, if left
They will
and
just
right,
do it by
left is
themselves.
more right. So let's say weight. Yeah, current
If
weight.
L equals R, that means you just go by itself.
Yeah, you're right. Weight. What's the weight? What's the current weight?
Oh, it equals left and right.
No. Weight. Weight what?
Left and right.
Left and plus.
Right.
Weights right. Can you?
Wait, right.
Yeah, right.
That's
Okay.
what I meant.
Okay, now what? Now what?
Oh, if L plus
No. Why is left? No, because we are not sure we want to pick left, right? Yeah? So it can only be right. Let's say we pick the right because the most heaviest will go anyway, right? Yeah? Yeah? The most heaviest will go anyway, right? And then R what? R what? When we pick the R, what should we do?
we add 1.
R is on the right.
Minus 1.
Minus equal 1, okay? And then now, look, if weight plus what? Smaller or equal limit. Can you tell me what it is? If the most heaviest plus the most, what?
Lightest.
What's the most
L.
heavy? L. What's that? Weight, L, right?
Yeah.
If that, then what should we do?
They will go.
Then we'll go. And then how can we mean you will go? How do we mean if we will go? How do we mean if we will go? The left pointer what?
Oh, left and right. Left left add 1 and right minus.
No, we don't need to write already here, right?
Okay.
And then here, when one goes, so what do we do with the count?
You can't add 1.
Yeah. Okay, and then return.
Return. Wait.
Return what?
Limit. Return.
How many sheets?
Count.
Yeah, return count. Yeah, today I didn't name you answer, yeah. I want to test you if you understand it. If I put the answer here, you know, return the answer, right? Yeah.
Got it.
You got it? What's the time complexity? Here. Here is, what's the time complexity? What's the time complexity? What's the time complexity of this part?
This is O-N log N.
And this part is what?
O-N.
Oh, N. So what's
So
the
O-N log N. O-N log N.
Why is that?
Because this one I had the most time.
Yeah, this is most time consuming.
And
The
it-
overall
and
complexity
it-
is dominated by this one, right?
And
Yes?
it's bigger. Yeah.
Ha! Okay.
I know.
And then there's one more. Come on.
Are you kidding me?
Yeah, I erased two. What happened to the count if I choose the?
Oh yeah, count. I'm not sure if I did it in right place.
So is it go with the if or is it goes with the y? I'm asking you.
If.
What?
Wait. Wow.
Why? Yeah. No, it's with this. Okay, if this is have a space. Yeah.
Why?
Does it make sense? Yeah. Alright. Look, if we haven't put all the weights in the spaceship, right? Then we pick the most heaviest. Alright. We pick the most heaviest. R minus equals 1. If the current weight plus the most lightest can go in the current ship, then we take that, right?
Mhm.
We take that. Let's belong to that. But anyway, we go. Yeah. Every iteration means that we let spaceship go. Am I right? Yes. Okay. That's it for today.
Bye.
Bye bye.